Okay, I fixed that. Okay. Hey guys. I already started this video. I got like 10 seconds in, but the audio wasn't working. It is now. I did a preemptive subscribe, a like. I guess this is episode 5 of a series. Probably architectural style series. This one's Gothic Cathedrals. I love architecture. Something I want to do more than anything else, if I had a wish, is to have a time machine that could teleport me to any place and time, but like I'm a ghost, so I don't actually have to like suffer through things. Just look, and one of the first places I'd go to is like medieval cathedral construction sites and see how they built them. I think that'd be so cool. Let's go.
Gothic cathedrals represent one of the high points in Western architecture. Their builders wanted to construct places of worship with upwards-looking spaces and light-filled interiors, features that spoke of the God they worshipped. To realize these grand goals, generations of builders from the 12th to 16th centuries were forced to make dramatic advances in both architecture and engineering. Their efforts gave rise to many innovations, including large buildings with complex vaulted ceilings, high stained glass windows, pointed arches that reduce lateral loading, and flying buttresses that can support tall, thin walls while letting the sun shine in. For thousands of years leading up to this time, most buildings were constructed using posts and beams. The vertical loads carried by the beams resulted in simple vertical loads in the posts or walls to which they were attached. Beams, however, could not stretch across the much wider spaces required for the new cathedrals. Arches, like this model, or this simplified model, could span these large distances. However, they generated large horizontal forces at their ends, and
Especially at the bottoms, right? Because if you put a weight right here, then it's going to want to push these two things down, which are going to push into each other, which is going to want to make this corner right here go up, right? And so you'd want really strong supports right here to keep that from happening.
they could collapse if those forces were not adequately resisted. Short, thick walls might be able to resist these forces, but the cathedral designers wanted tall, thin ones. And they wanted to put large glass windows in those walls so the sun could illuminate the inside of their cathedrals. The horizontal loads generated by arch ceilings would have easily
So that's why you need the flying buttresses.
pushed over the kinds of walls they wanted to build. One possible solution to this problem was to pile stone on the outside of the building so as to support the wall. Over time, the engineers developed structures called buttresses, and these elegant structures could be found in many early Gothic cathedrals. Unfortunately, they tend to block the sunlight, as this model demonstrates. In time, designers figured out how to build thin lateral supports called flying buttresses. The earlier buttress designs were essentially broken into separate tall pieces and moved a short distance from the side of the building. The resulting tall sections were called piers, and they were connected to each other and to the side of the cathedral using sloped arch-like members called flyers. As this model demonstrates, flying buttresses kept the tall, thin walls from collapsing, and they allowed the sun to shine in.
I was pausing for a second because I thought these bottoms might need some support, but I don't think there's much. I mean, the pressure from this arch is being put on this area, which this won't need as much support because it's
Kept the
right.
tall, thin walls from collapsing, and they allowed the sun to shine in. This drawing shows how the forces from the vaulted ceilings were transferred to the flyers and then down through the piers to the ground. Spires and other heavy architectural features were sometimes placed on the tops of the piers so that the lateral components of the arch forces could be more efficiently transferred to the ground. By spires, we mean the high pointed tips of the piers. As you can see, the resulting buttress systems can be quite complicated. Since the designers did not have computers to help them, they relied on scale models, the much more sophisticated ones than ours. Those models helped them to fine-tune their designs, and they showed them the right order in which to build the various parts of the cathedral so that it would remain stable during construction.
So, I'm assuming you have to make the scale model from the exact material that you are planning to use on the full-size model, right? And being extremely exact in the proportion of weights and everything, right? In order for it to be a good predictor of how it'll hold up.
In what order should the components of this cathedral be built?
Wait, what? Who?
Parts of the cathedral, and they showed them the right order in which those models, the much more sophisticated ones than ours. Those models helped them to fine-tune their designs, and they showed them the right order in which to build the various parts of the cathedral so that it would remain stable during construction. In what order should the components of this cathedral be built?
Okay, my main thought goes to the outside pillars. I feel like the arch is not the place to do it. I would say building first each of these columns and then connecting the smaller of the columns and then connecting the middle to the larger columns and then placing the arch.
Built. Let's try building the shell of the building first. Oh, that turns out to be a poor choice.
No, I agree on the first part
of the building first,
but not the arch. Do the buttresses here.
Oh, that turns out to be a poor choice. It's a good thing that this is just a model. Let's try again. This time, let's work towards the center and start with the most distant flyer. Then add the inner flyer, and finally add the arch.
Did it work?
If we take our hands away, the cathedral model stands.
Hey, did I say that?
The model has taught us that this is a much better construction plan. Once the stonework in a cathedral was finally completed, it was typically covered with a slate.
But why not do another of these buttresses into the ground? Like, why not do that?
Shingled wooden roof to keep off the rain. We hope this video helps you to understand why Gothic cathedrals are such a triumph of architecture and engineering. Besides their beauty, many Gothic cathedrals have remained in service for more than 700 years.
And these are all scaffolding holes, right?
And they continue to inspire those who visit them. We hope you will consider watching some of our other engineering models videos.
That was fun. I enjoyed that. Love y'all. Would appreciate any comments down below. I know that was a really quick video, but I like this stuff, so hope everyone's doing well. Hopefully I'll see you guys next time. We'll keep on learning. Bye, guys. Maybe do some history.